Okay, so topic 3, rates of change. Before we do problem 1, let's just go all the way back to some basic stuff here. What's the antiderivative of f prime? It is f. And if you do it like that, you'd have to say f of x plus c. If you did it with limits, let's just say a and b, slightly different answer.
F of x plus c with the bracket and from a to b.
Okay. Yes. Which turns into, Lexi, f of b minus f of a. So, yeah, Seth said do the previous thing but with the bracket in a and b. Sure, but it would be quicker to just jump to there. Antiderivative of a derivative gets you back to the original. Now, rates of change is an application of that. If we take the integral of a rate, which is usually with respect to time, although this question comes up at least once a year on the Facebook group, is what happens if the students switch x and t? And the answer is it doesn't matter, you're fine. Except in like rare cases, if a problem had x and t in the problem, well then you'd have to be careful. But if you accidentally swap x for t or vice versa, you're fine. Okay, if we integrate the rate is the derivative of the amount. Maybe we should have started over here. If f of t is the amount, then f prime of t is the rate the amount is changing. By the way, this is another very common problem. You look at the dates on these. And by the way, I don't remember when we put this together, 5 years ago or so. But 2018, 2015, 2014, 2013, 2010. So you don't want to get in the business of guessing what they're going to test, but this is a very common free response question. Okay, so if I integrate the rate, I get, especially if I do from A to B, I get the amount at B minus the amount at A. If you integrate a rate, you get, another way to say this is the change in amount. Most of the questions, they give you the rate and then ask questions about the amount. Usually. They could do it the other way, but almost always they'll give you a rate equation and ask you for a change in amount, and basically you have to recognize, oh, I just need to take the antiderivative of the rate to get the amount. Worry about the limits. Maybe I can solve for C. Maybe it's just f of b minus f of a. But this is the big thing for topic 3. Gets its own topic. If you integrate the rate, you get the change in the amount. All right, so let's look. We'll do number 1, but before we get into the details of number 1, look at the just big picture problem here. People enter a line for an escalator at a rate. So they're giving you a rate. You look down to number 2. The rate at which rainwater flows into a drain pipe is modeled by this equation. Number 3. Grass clippings are placed in a bin where they decompose. The amount of grass clippings remains in the bin is modeled by. Okay, this one's giving you the amount, and they're probably going to ask about the rate. So that one's sort of backwards. So be careful about, are they giving you the rate and asking the amount? Or are they giving you the amount and asking for the rate? Let's do number 1. Mental note or actual physical note. We're starting this at the 5-minute mark. You're supposed to take 15 minutes per free response question. I mean, they give them to you in chunks, so if you finish one in 10, you've got 20 minutes for the other. But generally speaking, it should take you 15 minutes. So I just like to see how long it takes, because usually it takes me 15 minutes, and I'm going slow and explaining things as I go. So we'll just see. So mental note, or physical note here, we're starting this one at 5:20 on the video. Okay, people enter a line for an escalator modeled by the rate, or modeled by the equation R equals, and this might be good practice in terms of AP day, because you're not going to have the problem printed out to write down. So you'll have to figure out, well, do I need to write it down, or can I just start answering the question? And that's going to be up to you. It's like, I might could have done this problem without writing it out, but I also know that sometimes I like to circle things and point out things, so maybe it's good to write it down. Up to you. Okay, where R is measured in people per second. Peoples per second. So this is a rate of people entering a line for the escalator. Hey, this actually kind of fits with what you did today this morning getting into school. So perfect timing here. As people get on the escalator, or as people pass through the metal detectors, they exit the line at a constant rate of 0.7 persons per second. So the exit rate, 0.7 people per second. Again, this is a good model for what happened this morning, because the people arriving at the metal detectors arrive at different amounts, but the people passing through hopefully was a fairly constant 0.7 per second. You're saying no, maybe not this morning, but it's similar to the escalator thing. There are 20 people in line at time 0. So people at 0 equal 20. Okay, so I got like 3 different things going on here, and I need to be super careful. R is the enter rate. I guess I'll call E enter and exit both start with the same thing. So I just need to be extra careful here. R is the entering rate, E is the exiting rate, and P is how many people are actually standing in line. So I've got some equation for how many are joining the line. I got an equation for how many are exiting the line, and I know that at time 0 we're starting with 20 people in line. Part A. And by the way, so we spent 3 minutes on this problem, and we really haven't even started it yet. We've just considered what they've given us and tried to understand the situation. Part A. How many people enter the line during the time interval 0 to 300? How many enter between 0 and 300? Oops. So I want how many, that's an amount, enter the line. So what am I going to have to do other than grab a calculator? How do I get the amount if I've got a rate? So how do I get from a rate to an amount? How do I get from a rate to an amount? What's that? Derivative or antiderivative? If I've got the rate and I want to go backwards to the amount, I need an antiderivative. So how many people enter the line? Will be the integral from 0 to 300 R of t dt. And that would be enough work to show, because your calculator is going to find that. So grab a calculator if you need. This is piecewise, but I'm not worried about the piecewise part. I'm just going to put that in for y1. 44 x over 100 cubed 1 minus x over 300 to the 7th. So yeah, I want no part of that, doing anything with that by hand. I definitely want a calculator. If you're afraid you're going to use Y1 in showing your work, it's okay as long as you label it what you're doing. Although I kept the RT thing, so I'm all right. So Math 9, 0 to 300 of Y1 dx. So that means 270 people entered the line. And you don't have to answer in complete sentences, although make sure your answer makes sense, right? If they ask how many people enter the line, you don't have to say 200 people entered the line between 0 and 300 seconds. It's not like when you're in middle school and you have to give the full answer that includes all of the statement. You don't have to do that. Part B. During the time interval 0 to 300, there are always people in line for the escalator. How many people are in line at time 300? How many in line at time 300? So I like that they're kind of walking me through this problem. I already know that 270 people joined the line, so I started with 20. And then we added 270, that was part A. How do I figure out how many people left the line? Let's see, we exited at 0.7 people per second. So for 300 seconds, this one's, you don't even have to really do an antiderivative. You can just realize that 0.7 times 300 would tell you how many people left the line. So 0.7 times 300 would give us the total number of people that left the line. That is the same thing as the integral from 0 to 300 of 0.7 dt. So if you're sticking with the calculus approach, it still works. But some of you would hopefully realize that I can just do 0.7 times 300. That would be a safe stop, but I got a calculator, so let's figure out how many people are in line. So that turned out to be 80. Again, they tell you not to box your answers. I just have a hard time not at least like saying, hey, here's my answer. But you don't even have to do that. Part C. For time greater than 300, what is the first time that there are no people in line for the escalator? So for t greater than 300, when are there no people left in line? So I guess the first thing to realize is after time 300, I'm not adding any more people. Thank you. So I've got 80 people. I'm not adding anybody because R went to 0 after 300, so nobody else is coming, but there are still people leaving the line, and they are leaving at 0.7 times t, and I want to know when that line gets down to 0. So, like the math on this particular one is pretty easy. So maybe your calculator dies, you just leave your answer is 80 over 0.7 seconds. So 114 seconds later. 3 decimals, 114.286 seconds later. So from 0 to 300, people are coming to the line and leaving the line. At 300, there's 80 people in line. Nobody else is coming. We're just feeding them through the metal detector. And after 114 seconds, the line's empty. Part D. For 0 to 300, at what time is the number of people in line a minimum? To the nearest whole number, find the number of people in line at this time. So when is the line a minimum? And how many people are in line at that time? Justify your answer. Okay, again, if it says justify, you probably want to justify first to know where we're headed. So the line is a minimum when the rate of the line, or the derivative of the line, changes from negative to positive. Yeah, that's always true. A quantity is at a minimum when its derivative changes from negative to positive. So the rate is the rate in minus the rate out. Rate in is what we put in for y1. The rate out is 0.7. So I don't know if I want to call this like the net rate or the total rate. I got some people coming in and some people leaving, and I want to know where that changes negative to positive. And the good news is I've got a calculator, and I've already got R1 in there, or Y1. So I'm just going to go to the end and put minus 0.7. So R, people in, minus 0.7, the rate of people going out. And I'm looking for where that changes negative to positive, somewhere between 0 and 300. The y value doesn't matter to a whole lot because I just want to see where it changes negative to positive. So 100 to 100 is too much. I need to zoom in some more than that. Yeah, because there's not 100 people per second arriving. That would be a little much. Let's go negative 10 to 10. There we go. Okay, so I'm looking for negative to positive. I'm going to zoom in a little bit more. So that first one is negative to positive. Then I've got a positive to negative, so that would be where the line is at its biggest. And you can kind of see it dies off and then people are just leaving. So, second calc 0. I want negative to positive, so I want that first 0. Left bound, right bound, guess. So at t equals 33 point, carry 3 decimals, 013. Actually, I may need to carry more than that because I'm going to have to plug that in later to find out how many people there are. So 33.013298, just to make sure. Line is a minimum. So now I need to figure out how many people are in line at time equals 33.013298. So, let's see. We started with 20. We want to add people from 0 to 33 point ... R. And then we know they're leaving at 0.7 times 33 point ... So I'm going to save that number, store that number as A. There we go. And then I'm going to type in my calculator what I just said. We started with 20 people. We're going to add math 9, 0 to A of y1. So there's how many people we added. We're integrating the enter rate, and then we will subtract the exit rate, 0.7 times A. Uh-oh, what did I do wrong? Did something wrong. Because we shouldn't have negative people in line. Oh, I know what I did wrong. You might know what I did wrong. Oh, this is a dumb mistake. My y1 changed because I put in the minus 0.7. So I need to get rid of that. I did that for the graphing purposes. Now if I do this again, hopefully I get a positive number. There we go. You can't have 3.8 people, and I think it said to the nearest whole number. So people at time equals 33.013 is 4 people in line. Alright, that last part is hard, but remember, the last part's always hard, and you only need a 50% to make a 3, so, get the first 2/3 or 3/4 of the free response questions right. Maybe you stumble into one that's easy and you can get all of it, but you'll still be fine. The timer's at 21 minutes. We started at 5:20, so that took us 16 minutes. Supposed to take us 15, so that was a little longer, plus I try to explain and write down everything as I go. Okay, number 2 is pretty similar, so right now I want you to try number 2. Then we'll do C and D together, or I'll do those. So, number 2A says how much total flowed into the pipe. All right, gentlemen, back to number 2. How much flowed into the pipe? So I'll take the antiderivative of the N to get the change in the amount. So the amount that flowed in is the antiderivative from 0 to 8 of R of t dt. I'm using y1, so there's how much is flowing, or how many gallons have flowed in. And it didn't ask me for units, so I'm okay. Cubic feet is the unit, but they wouldn't take off even if you put the wrong unit, because they're not looking for units. Part B is the amount of water in the pipe increasing or decreasing. So that's a rate question. Well, at time 3, there's a rate of the stuff flowing in and a rate of the stuff flowing out. So I need y1 at 3 minus y2 at 3 is negative 0.314. So what does that mean? Is there water going in or water going out on the net? Out. So water, well, there's always water flowing out. So let me see how I word this. Is the amount of water in the pipe increasing or decreasing? So water is decreasing. There's more going out than is coming in. Yeah, that makes sense. R is how much is coming in. D is how much is going out. There's more out than in, so the water level is decreasing.
How did you go Y2? What was Y2?
So Y2, I labeled it up here so that I could switch back and forth between D and Y2. You don't have to do that, but if you're worried you're going to type or write Y1 and Y2, then make sure you've labeled Y1 and Y2. I would not need to do that. I could just say R of 3 minus D of 3 and get my answer.
Okay.
Part C. At what time is the amount a minimum? The amount's a minimum. So, I have to draw it out every time. When the total rate or the net rate changes negative to positive. So that's what I'm looking for. And the net rate is the rate in minus the rate out. So I'm going to look and see where does R minus D change from negative to positive. Let's see. I've already got those in. I don't really want to retype them. I can use the calculator to graph previous, like I can still use those variables. So I can do y1 minus y2. Because that's really what I want to see right now. I don't really care to see the individual pieces. I just want overall y1 minus y2. Let's see. This needs to go 0 to 8, not 0 to 300. And I have no idea what my y value should be, so let's just see if 20 to 20 looks like not very good. Although I can still see where it goes negative to positive. I would like to see a little bit better. So I'm just messing with my window so I can see it better now. Is she zoomed out too far or zoomed in too far? If you're zoomed in too far, you will see the x-intercept, but it'll look more like a straight up and down line. If you can't see it at all, if it looks like a flat line, you're zoomed out too far. So my window is negative 5 to 5 for the y values. 0 to 8 was easy because they told me what x values to use, so I knew that, and then I just had to play with the y values until I got something I like. Second Calc 0. So that happens at time equals 3.272. All right, it's 3/4 of the answers. By points, it's probably 2/3 of the problem. But still, if you make it that far, you're on track for a 4, maybe even a 5. So let's see if we can get part D here. The pipe can hold 50 cubic feet of water before overflowing. For a time greater than 8, water continues to flow into and out of the pipe at the given rates until the pipe begins to overflow. Write but do not solve an equation involving one or more integrals that give the time when the pipe will begin to overflow. So I want to know the amount, or I want the amount to equal 50. So I need to come up with some equation, probably involving an integral, since it said that, to get to 50. And it said to use time equals W, so okay, so we started with some, we added some, and we subtracted some. So back to the beginning of the problem, how much did we start with? All the way back 30. We're going to add some. That was the R equation, was how much is flowing in. We're going to subtract some. That's the D equation for how much is flowing out. And we want to know when that equals 50. That's probably enough for a point or two. I'm guessing that's a 3-point problem, that little piece of it. What do my limits need to be on R and D? 0 to we don't know, so that's where we'll use the W. And I couldn't solve that, but that's because that's okay. It says write but do not solve. We started with 30, we added some, we subtracted some, and whenever that equals 50, then the pipe is full and we're overflowing, and who knows what disaster is happening. Oh, unintentional, but look at the timer there. Right at 30 minutes, and we did 2 problems. So, right on track for time. Again, always try all the parts of those free response questions. They don't always flow nicely. Like usually they start easy and get harder, but occasionally they throw a hard one in the middle and the last one's kind of an easy one. And so if you get stuck somewhere, don't be like, oh, done with that one. Well, I can read the next one and maybe you can figure that one out even if you couldn't figure out the previous one. Like this one, C and D are not really related to each other. If you forgot about finding a minimum, but you knew about finding amounts, you could get Part D without getting Part C. So try to get all the points you can. Okay, I want to make a minor change here. Instead of you doing number 3, I want you to try number 4, because number 4 is really close to 1 and 2. And that's the more common problem. They give you a rate in, they give you a rate out, and then ask all kinds of questions. And that matches what number 4 is. Dang it, there's only 15 minutes left. Okay. So, with the last 15 minutes, let's look at the multiple choice. So again, your job is to try number 4 at some point. This packet's due Monday. You'll have 15 minutes. You'll have time tomorrow to work on it. Well, let's do some of these. I was going to do a game today. Could do the game tomorrow. But I want to play catch up tomorrow. Not play a game tomorrow.
Play catch up and a game tomorrow.
We could do that. This video is stopped.
Stop today? I agree.